in question 3, we explore the relationship between the distance that the water is from the crest, that's the top at Shasta Dam, and the length of the perimeter all the way around the lake. And if you think about it, as the water level increases, the lake becomes larger, and the distance around it grows as well. But if we're measuring the distance from the top of the crest, as that distance from the top increases, that means the water level is going down. But as that distance from the crest increases, the size of the lake would decrease. So that's what we're exploring here. And the first thing is there's a set of data, and we're asked to find the least square regression line and ask, does this model appear to fit the given data? So I'm going to take this data, whoops, let me bring it over here. That's better. Let's bring the calculator over. So I'm not going to enter all the data points with the video recording, but in order to get to where I can edit the data, of course I hit stats and I go to edit. If there were some values in the data set that we needed to clear, remember to clear those, it's best just to go up to the very top where it says list 1, press the clear button, and then enter. So now I can see it's ready for it. So for distance from the crest as my x values, I'm going to enter the 0, 62, 127, 132, 152, 162, and then finally 197. And miles of shoreline. So we start out with 365 miles if it's a completely full lake. In other words, the distance from the crest is 0, so it's all the way up at the top. If it's 62 feet down, if it's 62 feet from the crest, then it's 295 miles of shoreline. Then it goes to 217, and then 211, and 181, 175, and then finally 147. Okay, so all this data is in now, and probably a good idea, because now that I'm not typing it, just to check it back: 365, 295, 217, 211, 181, 175, 147. That's perfect. And I'll go from the bottom up: 195, 162, 152, 132, 127, 62, and 0. And my eyes are just kind of going back and forth between the value in the table and what's over there in the calculator display, just to verify that they match up. Okay, so now that I have that, I'm going to go ahead and perform linear regression to figure out the least square regression line. So I'm going to hit stat, go over to calculate, and option number 4 is linear regression, so I'll press that. My data is coming from list 1 for x's, list 2 for y's, and I'm just going to come down here and hit calculate. And it just came up with an equation that is attempting to fit this data, right? The equation of the line of best fit the least square regression line that I have here, and I guess I'm going to round these values to the nearest tenth, is y equals 1.4, I guess I'll round it to 5, so negative 1.45x, and then plus 363.59, so plus 363.59. So this is the linear model that we have, and it asks, does this model appear to fit the data? Well, there's a lot of things I could do to try and address that question. One of the things I'm going to do is quickly take a look at the graph of the data. So I'm going to activate a stat plot. So I'll turn on plot number 1. It's going to be on, and again you can see it's reading my data from list 1 and list 2. And now that that's all set up, I'm going to ask my calculator to go ahead and zoom the statistics. So I'll hit zoom stat, which is I guess number 9. Let me verify that. Yeah, zoom stat number 9. And here is the graph of this data. part of this, I mean, kind of it looks like a line, but also I'm wondering like if maybe there's a curve that would fit it better. But let's go ahead and plot the line as well. So if I hit y equals, I can grab this line by it's stored every single time I perform a linear regression. The calculator automatically restores all my residuals, and it also stores the equation of that line of best fit. So it's in vars. So I hit variables, and I go down to statistics variables. It's the equation, and it's the regression equation. So I can grab that, and then I can hit graph again, and now here's my data with the line of best fit superimposed over it. And to be honest, that looks pretty good. I noticed that the question below asks what's the correlation coefficient for this, so I might go grab that now, because really that might help me decide if it's a good fit. The other thing that would help me decide if it's a good fit is looking for some kind of a pattern in the residual plot. If I wanted to view the residual plot, thanks to, I think it was Porter that showed me this trick. If I go in and I view my stats right now, my stat plots, I'm going to go into the second one. So I've got this one always set up now with my y's being the residuals, and that's a list of data that's automatically generated whenever you run a regression. So I'm going to turn on this residual plot, and I'm going to go up to plot number 1, and I want to turn this one off. So again, this is just set up now, so every single time I come up here and I ask it to go to plot number 2, it's always list the values in list 1 are X, and the residual list is going to be list Y. So I can right now hit zoom and then zoom stat again, and now I can see the residual plot. This is just perfect. In fact, I think I can drag these. Yeah, I can. So I can take these and drag them into the notebook. That's a great trick. I forgot I could do that. So this is what the residual plot looks like, and as far as the residual plot goes, you can see that there's there's some kind of a pattern here, right? It's like kind of going high and then low. I don't know if there's enough there for me to be concerned about it, but I do kind of see some kind of a pattern in the residual plot. So if I was interested, I might take a look at maybe some exponential curve or something to fit with the data, but I would say there's not enough data here for me to really get excited about this. So I'm going to say, yeah, the linear model is probably a pretty good fit. So I'm just going to say this appears to be a good fit, but I may want to consider exploring other models. Let's go ahead and figure out what the correlation coefficient is. Somehow on this calculator I've turned off diagnostics, and because of that I can't see them. If you want to turn diagnostics on, it's one of the catalog items. So I'm going to hit second and then catalog, which is on the 0 button, and I just have to jump down to the letter D, and there's a shortcut. Because alpha is selected right now, I can just hit the letter D, A, B, C, D, and it'll jump to the D's, and then I'm just going to go down until I see diagnostics on. There it is. So diagnostics on, so I'm going to press enter and enter again, and it says done. So now if I go in and I do the regression again, so second calc linear regression, not only does it give me the line of best fit, but it also shows me the value of R, with my correlation coefficient. And it makes sense that it's negative because this does have a slope that's going downward. So you can see the R value is 0.9975. So R equals 0.9975, and it's negative, don't forget that. So this is it's a negative correlation coefficient, and it tells me that there's a very strong association between these two variables, right? The two variables being the distance from the crest and miles of shoreline. There's an obvious relationship between these two. So in this next question it says, is the correlation coefficient R positive or negative? So I'm going to say it's negative. And it says, what does this tell you about the relationship between distance from the crest and miles of the shoreline? So I'm just going to say these variables have a strong association. And the final thing I have here is it says, predict how many miles of shoreline Shasta Lake would have if the water level was 250 feet from the crest. So going back to our model, which was it was y equals negative 1.15x and then plus 363.59. The question is if the water level was 250 feet from the crest, that's an x value, right? It's not that they're not giving me the miles of shoreline. They're giving me the x value and saying what would be the y value that would go with that. So in order to answer that question, right, I could just plug in this value of x and solve this expression for y. When I do, I get about 76.09 feet. So is that right? So this is a very actually these are not feet, these are miles, right? So it would be 76.09 miles. And considering that in our table at 0 feet, right, full pool, the lake is 365 miles. That seems kind of small to me. In fact, it makes me question whether or not I should be using a linear relationship, but I digress. Another way that you can see this too, if you remember, if we go back to our let's turn back on the right scatter plot. So I want to turn this plot back on, and I want to turn off the residual plot. So let me turn it off. So now if I hit zoom 9 and take zoom 9 and take a look at it. So when I'm taking a look at this this way, I don't think I can enter. I think some of you are having problems with this. So right now I'm on the oh yeah, I have to hit trace. So if I hit trace, I'm on the data set, and now I'm on my the equation. So I can toggle between the data set and the equation. I think the problem that some of you were having was you were on the equation, and you know that if you enter 250, for example, and press enter, it should tell you what the y is. But notice what's happening here. It's an invalid value for the view of this window, right? So I can change the window, right? I need an x value to be larger than it is. Right now my maximum x value is 216, so I can come in and say, oh, let me make my x value 255. So if I make my x value, the largest x value, 255, now I can come in here and with trace, I can get my cursor on top of that's the data, now it's the equation. And I can now say, look, if x is 250, what's the y value? And it jumps to it there, and you can see it's 70. That's interesting, 76.9. Oh, I know why. There was some round off from this. I rounded these to the nearest tenth, so that's why there's a slight discrepancy there. But it's about 76 miles of shoreline according to this model. The last thing that you're asked to do is go through and plot the data. That should be a fairly simple activity. I'm just looking to see that you can plot the distance from the shoreline, or distance from the crest on X, and the miles of shoreline on Y, and then overlay on top of that the least square regression line. And it does say a sketch, but making it as accurate as possible is a good thing. Okay, that was an entire page of this test. That was just question 3, and we're done.